last week's lecture and attended the quiz?
Yeah, 4th week we have gone.
Week 4 you have done, and how was it?
Like finding out the answers for the problems based on graph was little difficult.
Okay. But the questions were difficult than what we solved, or it was similar?
Some almost similar, but I was taking more time to solve it.
Okay, so let's start this week's topic. So maybe we can do one thing. We can start with the question answers first, because last week also I didn't get proper time to finish all the questions. So this week I'll start with the question answers that I am having in my PPT. Let's solve it, and then we can start with the topics what have been covered in this week. Okay. Is it visible?
No.
Now?
Yes.
Now it's okay.
So just a briefing on the topic. So this week the liquid aim process was covered. Like you already know about this chart, and by combining various different systems together, you can get various processes under the state of the art of VAT photopolymerization. For example, this 3D systems, SLAs, affair, microstereolithography, object polyjet, etc., etc. So these are the systems, and by combining these 5 options in alternative way, you can get different systems. So that has been covered. And then next was
Excuse me, madam.
yes.
Regarding the solid ground curing,
Yes.
I think the option, the kind of the light we use, I think it is mentioned as actually some correction is required, I think.
Where is the question?
Just you show me the earlier slide for various.
Earlier slide. This slide.
Yes, yes.
Okay.
Yes. Here.
Yeah.
For the case of solid ground curing, where we use a mask, it is given as a liquid VAT. Actually, in that actual slide where we.
Okay. Can you tell me the page number of which PPT or which PDF? Then I can go to that page.
I think that slide actually it is from 3rd week.
3rd week. Okay. So let me just open the 3rd week lectures then.
Various combinations.
Okay.
That,
just a second. Let me open the 3rd week's lecture PDF. Then we can find out your doubt. Okay, so these are the lectures. How to minimize this thing?
various combinations.
This is the tool path. This is not the PPT. Then this one. Combinations were there in the 4th week's lecture. This.
Yeah. Afterwards, yeah. This one mask.
Yeah.
is there now. The last in
Mask.
scanning system, mask is there,
Yes.
and yeah, ma- a mask and the lighting is a floodlight. Yeah,
Floodlight. Yeah.
floodlight. And what about the shape of liquid?
Here it's given VAT, liquid VAT. So is your
Okay.
question like it's not liquid VAT or you are
Yeah,
doubtful?
is it liquid wet or something else? Is it liquid jet or liquid wet? That is a doubt I have.
It is liquid VAT as per what I can remember. I don't remember all the processes actually, to be honest, because these are a lot of processes. But from the mask perspective, mask is only possible in the liquid VAT only.
No, where each and every layer actually we are uh,
Putting
jetting,
the
no, by
mask on.
material jetting, liquid jet, I think. Mask is only for SLA.
Actually, solid ground curing
No,
or
no,
whatever the process name
liquid
is.
wet is SLA.
Okay, your voice is a little bit cracking. So can you repeat the last line?
Yeah, for SLA we are using liquid wet,
Yes.
uh, but solid ground curing
Hmm.
we are using mask.
Yes.
Whenever we are using mask, the liquid is in terms of layers we are jetting actually. That is, light is not, it's not laser.
Hmm.
It is supported by wax actually. The
Hmm.
supporting system is wax.
Yes. Yes.
That confirmation I require.
Okay. So your question is whether it's VAT full of liquid or it's the liquid jet.
Yes, yes, exactly.
So how does mask work? It's basically they make mask for each uh,
In
layer
every,
and they put
yeah,
it and then they expose it with the UV light
not
and
you.
the U
Yeah, it is a floodlight. Okay.
yeah floodlight like UV or laser or whatever it is. It's basically UV light something. See shape
Yes,
of
yes.
UV light. So its wavelength is in UV mostly. So they put the UV light. So basically in this process, I think what I can remember is it's neither jet or nor VAT. It's kind of recoating that it puts the one layer of resin.
That is, it is a liquid. It's a full liquid in a container. No.
Yeah, yeah, but I think there should be another option here. Your doubt is right, actually. There should be another option where you can put the recoating also, like how you spread the liquid resin,
Yeah, actually,
and
for
it should
every
go
layer,
there.
yeah, in that case, for every layer, the uncured resin we are
Hmm.
um, removing by with the help of vacuum. Then we are
Yeah,
filling it with wax.
yeah,
Then
yeah,
again
you're correct.
another coating we are giving.
Yeah, yeah, it's coating. It's not jet actually.
Actually, yeah, it is coating kind of thing
Yeah,
only.
maybe because
Like
as
recoat.
it's coating the whole surface with the liquid, that's why it's coming under liquid VAT. It can also be one case.
Hmm. But
So in case
in
of
the
VAT, what happens? The whole bill plate covers with the one layer of resin, and in the selected area, the resin get cured. And in case of liquid jet, only in the selected area the resin will come. In the other portion, the resin will not come. So in case of this SGC, as we are not having another recoating option here, then maybe that's why they have chosen this liquid VAT option, where the full bill plate was covered with the resin. It was not the resin. It was not like the resin was coming in the selected area.
yeah, it is a complete layer,
Yeah,
but it is not VAT. No,
not a
VAT
VAT.
means
Yes, yes,
is the container with
yes.
full of
Yeah, yeah,
resin.
yeah, yeah.
But
That
that is
is
not the
correct.
case.
So it's I would not say wrong because they have put it with some logic. So that's why I would say that if it were having another option of recoating, it could have been better. But as it's not there, so that's why it's okay to put the liquid vat, as the vat concept is also to cover the whole build plate area with the resin, which is not the case in the liquid jet.
Yeah. Okay.
Just a second, I have to receive a call. Just a yeah. So next, do you have any other doubt?
No, no.
So can I start then week 5 topics?
Sure.
Yeah. So it's better to note down the formula from what I am going to show you via the questions. When we are done pointing out the formulas for each question, then we can move on to the topic that has been covered in this week 5. So just if you have read the topics, just try to answer. In the context of using the telecentric lens, which if the following is true, which of the following is true? The scannable area does not depend on the size of the lenses. It facilitates the normal incident of laser beam into the target plane. Any guesses? If you have not read the videos, watched the videos, then it's not possible. So the scannable area does depend on the size of the lens, because the lens fixes how much area can be covered, and by that we calculate how much build volume is possible to take. And it facilitates normal incident of laser beam onto the target plane. So just remember, the telecentric lens is used so that the laser beam can incident on the build plate at a normal angle like 90 degree, and the f theta lens is used to make the laser beam focused in all over the build plate. Next, if the f theta lenses, the laser beam spot position has the following relation to the angle of incident of the beam of the lenses. So it's directly proportional. So you can note down the points from the question. You can sit with the pen and paper and note down the important points from the question and the answer. Next is the figure shows the cross section of two elliptical cylinders to be manufactured separately by 3D Systems SLA. So how does it work? So in the recording system, if the time required for deep dipping in any layer of the object, this too, then the following statement is correct. So let me draw one circle. So when the question is related to the time of the deep dipping, there is one term called critical radius of the geometry. Critical radius of a geometry means if you can draw a circle in the geometry, the biggest circle that you can draw inside any geometry. So this is an ellipse. So the highest circle, the biggest circle that you can draw inside this ellipse can have the diameter as A, because this is A.
Minor axis.
Minor axis. So it will be equal to the minor axis. And for this, the diameter will be A. Okay. And the relation is the time relation is proportional to the critical diameter. So it will be A is to A. So the time will be same for both. You can see later, you can later watch the video and then you'll understand more why it is so. In the context of the 3D systems SLA process, the gap between the doctor blade and the pre-built layer is 10 micron. So if this is my VAT, and this is my build plate, and this is an object made. Till here, the VAT is filled with resin. And now it's my second layer. So this is the layer thickness. So if this layer thickness is 10 micron, what will be the obtained thickness of the layer? Like this is the thickness T that we are going to obtain. But for that, we have maintained a distance between the last layer and the doctor blade, that is 10 micron. So the formula is TL equal to LG by 2. LG is the gap between the doctor blade and the pre-built layer that you are keeping, and the ultimate layer thickness will be half of it. So it will be 5 micron. So you can write down this formula, PL equal to LG by 2. If you have any doubt, just stop me in between. Okay, next we have a single axis galvanometer with a range of 25 plus minus degree used in SLA process. The laser beam deflected from galvanometer passes through a flat filled lens to keep the focal point distance at 750. So F is 750. What will be the difference between the maximum and minimum angular velocity of the galvanometer? So angular velocity formula is this. For maximum, it's 0, like cos 0, it's 0 degree. So this is the minimum velocity that you can get using this angle, and the maximum velocity you can get by putting the angle as 0. So this is the maximum and this is the minimum. So the subtraction will be 1.2. What will be the difference between the maximum and minimum angular velocity? Next is the similar question in which you have to find out the W mean with the different angle. So now the angle is reduced to 20 degree. So it's flat filled lens again. So the formula remains same. The maximum you already know, but you need to find out the minimum one with 20 degree. So just put 20 degree in the formula and we are done. So you can write down just these two formulas. These are the important ones. And write down that what are these terms. Like this is the angular velocity. This is the normal velocity.
Ma'am, for maximum, is theta 1 for 90? Cos theta is 1.
Yeah, cos theta is 1. Theta is 0 degree.
90 degrees. Okay. The formula is in terms of velocity, no?
Yes.
It is V.
Sorry?
So Vn equal to F secant square theta Wn.
Yes, F is the focal distance or focal point. WH is the angular velocity. VH is the normal velocity.
Linear velocity.
Yeah, linear velocity, you can say. And cos theta is the angle through which or up to which the galvanometer can rotate the or can move the laser beam.
So maximum we are taking theta at 0 degrees.
Yes. You will see why we are taking theta as 0 degree. I'll show you the PPT as well. So right now, let's just complete the questions first and then PPT. Okay. Next, we have in the question number 6, that is where the theta was 20 degree and the highest minimum velocity was got as 8.83. The value of f is 0.5 mm. Find the constant velocity of the laser beam. So we have to find out the VH. So the formula is same. Now we already know the maximum velocity from that. So there you have to just put the 0.5 thing, and now you can get the VH equal to 5 mm per second. The formula is same. The same
Excuse me.
formula, you have to just
In the
read
earlier
the question carefully.
in the earlier formula, cos square 2 theta is used.
No, just theta.
Earlier slide, cos square last one, cos square 20 it is.
Theta.
It is
Yes.
maximum also.
In maximum, cos theta is 0, like cos 0 is 1. So it's 1.
That is 6.67.
Yeah.
And minimum is when theta is 20.
See, it's written maximum angular velocity is 10. And theta is 20 degree. So this one we already know, that is 10. And now you just multiply it with cos square 20.
Yeah.
Okay. Now here we are using the same formula, that W max is 10, but now F is 0.5. So now we can find out what is VH. 5 mm per second. The ratio of deep dipping time required for the two cross section is given. The amount of deep dip is about 10 mm for cross section 1. So what will be the amount for cross section 2? So there is a big relation also. So in which we get that the amount of deep dip, like the height of deep dipping, is having this direct proportional relation with the square term. So T1, T2 equal to LD2 by, sorry, inversely relation, but with square of it. Okay. So now 1 is given. This one is given. So we have to find out the HD2. H, deep dipping amount for cross section 2. Okay. So I'm going to the next slide.
And what is the answer?
This is the answer. 22.36. You can do one thing also, you can just write, note down the values and then calculate it by yourself so that in exam you'll be fast in calculation. So next is the graph represent the relationship between recording time and critical radius. So it's very simple. When the recording time increase, the critical radius increases, so the recording time will also increase. So it's just directly proportional, straight graph. Like what, how much big the critical radius is, it will take more time for the deep dipping or for the recording as well. Next is, in the context of recording cycle in 3D systems SLA, put the following steps in right order. So the options are, like the options for the questions are Z weight, obtaining build position, deep dipping, leveling, elevating, sweeping. So here, if you see, two options are almost same. So that was a problem in this question. So I don't know how they evaluated it. But if this type of questions arrive, no problem. They will consider as a positive marks for all of you, I think. So it's first we do leveling, then we do deep dipping, then elevate it, then sweeping. Sweeping means sweep out the excess resin from top of it, obtain build position, like come to the actual position of the build plate, maintaining one layer thickness resin over it, then Z weight, then wait for the resin to settle down so that there is no vibration or turbulence in the liquid. Then we start the exposure of the UV light. So this is the order. You can write down the order. Okay. So a photosensitive resin is not employed as a build material in which of the process? It's RFP. So does anybody remember the full form? Can you? There was a noise. Any guesses? Do you remember?
It reinforced or resin.
Photosensitive resin is not employed as a build material, which of the process?
Yes.
RFP? What is
Yes,
the full form?
RFP full form. Do you remember or do you recall? Have you do you know anything about RFP?
Request for proposal.
Can you repeat? Your voice is not clear.
Request for proposal.
No. It is rapid something. A request for proposal is a different thing.
Rapid prototyping.
It's something related to the rapid prototyping of under VAT photopolymerization. Actually, I also don't remember the full form, but it was in the slide. Okay, for the time being, we will just note down this short name and then we can find out what is the full form. Okay. So minimized support and reduced cycle time associated with the perfectory aim system improves
Factory.
So it's both part quality and build speed. So if in any aim system, if you are minimizing the support, obviously the build speed will increase. And here the part quality is also improving, because when you remove the support from the part, there you get the surface roughness also. So indirectly, if you remove the support, then you can increase the part quality. Okay.
To remove the support, we can increase the part quality.
So basically, it goes like when the support is needed, you have to put. But if you can orient the part in such a way that you can just avoid putting support, then it will increase your build quality as well. Because when you remove the support, there will be some dents and your surface roughness will be more when where you remove the support from. So that's
Support
why.
is better quality.
Yeah. So if you remove the number of support, then better quality.
And
After
cycle
cutting.
time less means build time will be reduced.
Build time will be reduced. Minimal support is reduced, so build time will be reduced.
If there is minimum support, will it reduce the surface roughness? Is it like that?
Yeah.
Okay.
Because when you have to cut the support from the build, now when you cut the support, there will be some marks of the support, residue marks and dents in your part.
Imperfections will be there.
Yeah. So that's why the surface roughness and the quality will not be good in that portion. You have to go for further post processing for those parts. And in some cases, in some geometries, the support will be so much intrinsic that after removing the support, you can't even go for any post processing to cure that surface. So that's why. So the support removal mechanism employed in object polyjet AM system is water jet. Water jet is a process in which high pressurized water beam of water actually is provided to cut the part. There the heat affected zone will be very less, and it's a very precise cutting. And if the projection is not good, then it can destroy your part as well. But if you are using water jet, then you can smoothly remove the support.
These things are not covered in the lectures.
All the things may not be covered, but maybe there was 1-2 lines from each thing. There is no question in which you cannot find in the PPT or the lecture. Maybe the questions are not in the PPT, but sir has at least mentioned all the things once in the lecture videos. So you have to watch the videos very carefully and note down all the point he's saying. Okay. An optical mask is employed. This we already have discussed.
In SGC, just now we discussed.
Yeah. So the curing source adopted in AutoStrad's e-dirt system. A little bit a question which you need to remember. So it's laser beam. Then a top feeding type recording system is used. Again, it's a remembering question. So here you see it's saying top feeding.
Perfectory AM system. What is meant by perfectory AM system?
It's same solid ground curing.
No, perfectory AM system. What is that?
Again, I don't remember the exact process, but I can show you from the PPT. What are the topics it's using? Just remember perfectory AM system. We'll come back to it when I'll start the PPT description. Okay. I'll tell you. Which one of the following is associated with two laser beam SLM? So it's non-uniformities in the refractive index. Because if you are using two laser beam SLA system, means two laser beam is employed at the same time. So there, if the laser beam is not having exact same wavelength, then there can be slight difference in the refractive index in the resin. So that's why uh, in these four options, non-uniformities in the refractive index will be uh, closely bound question or problem associated with the problem with SLA with 2B. The support structure material employed in solid ground clearing is none of the above. It's you already have told. It's the wax.
Other solution. None of the above. Because that table itself will act as that abstract
What thing? Can
substrate.
you?
No, the table itself will act as some substrate.
Yeah.
So no other external support is required.
Yeah, yeah. So the wax you are also putting, na, that is also working as a support structure.
But initially, in the beginning,
Initially, the substrate,
initial support for the first
the,
layer,
the table that you are talking about, that is called a build plate.
yeah, bit plate,
The build plate is the initial support.
initial support. So
Yeah,
later on, wax
yeah.
support.
That build plate is the initial support for every kind of AM system because everywhere you will use a build plate for the printing.
But in SLA, only in the top layer, actually, the remaining liquid, which is below the first layer,
Hmm?
only the top layer will be cured, and below that you have the liquid, no?
The top layer. No, no,
There,
no, no. You're talking about that vertically upside down process?
no, top only.
Top only, na? So in top, you start as if there is only one layer of resin present in between the vat surface and the build plate.
Yeah, lot of resin we are using, no, in vat.
But the laser or the UV light is coming on top of the build plate only, not in the whole resin. The build plate is where you are starting the building process from.
Yeah, there, yeah. That elevator
Yeah.
stand.
Yeah. So that stand exactly that is called plate, build plate
Yeah, build plate.
or the
There,
substrate. So substrate will be there in every type of process. Otherwise, you can't make it in air or liquid. You have to have
yes, yes.
a base. So
Yeah,
the
some
base
support.
is always the initial support.
Yes.
So the last second last is in DMD for on and off state. So it's basically a question that you can get from the video only if you are following the video. So right now you can just note down the question and later on you can watch the video. Okay. And the last one is again a sum. So in 1280 cross 1024 resolution DMD, if the selected work area is 200 cross 200 and the voxel volume is around this, then what is the layer thickness? So you need to understand that in the LCD or LED screen based processes of wet photopolymerization, the resin gets cured only where the pixels get activated. That I described in the last class as well. So even if the pixel is getting activated, you will get the area to be cured by the pixel. But what about the height? So by which you can actually get the voxel or the cube of the the cube corresponding to the pixels that can be cured for each layer. So it's a very simple sum if you understand the meaning of the question. So the work area we already know. This is the work area because sorry, this is the work area that has been given, and this is the resolution. So resolution means this is the whole area. So area per voxel or area per pixel is this much. Now the volume of each voxel is given and the area of each voxel you can get. Voxel is the 3D name of pixel. Pixel is 2D where only X and Y direction is there, and voxel is when you count the Z as well. So layer thickness is basically volume by area. So this much is the layer thickness. So it's very easy question. It's not very tough, but still I would say you can just write down the formula. Next, I have some question from the previous year assignment because I was the TA from this course last year also. So these are the last year questions. So it's almost same question, same way. The focal distance is given, then the maximum speed formula you know, and the minimum speed formula you can put the 20 degree in it, and you can calculate the difference, and this is the answer. This is the same question, but you can take the question as your reference to solve it and see if the same answer you're getting or not. I will anyway upload this PPT in the Google Drive. Next, in the F theta lenses, the laser beam spot velocity is proportional to the angle of incident of the beam on the lens. Then we have a question on the F theta lens. So in this F theta lens, we have the range of 30 degree that is possible, plus minus 30 degree. Now, to keep the focal point at a distance from top of the resin surface, and this is the height, which is R, the area of circular laser beam spot on the resin surface is 2 mm square. Here, what will be the laser spot area if it's deflected through the galvanometer by 30 degrees? So this is the formula. If it's normally incidenting, then it's A0. That is 2 mm square. But if it's deflecting through the F theta lens, then it will increase its area a little bit because of the deflection, and it will go like the area by cos theta. So theta is 30 degree. And this is your answer. Get it? Next, we have a telecentric, a telecentric lens facilitates the incident of the laser beam from top of the surface. I have already mentioned the telecentric lenses are used so that your laser beam can fall onto the surface perpendicularly so that you can maintain same spot dia in all over the build plate. And F theta lens is used to maintain the focus this point on all over the build plate. Select the correct statement. So the build area is limited due to small size of the telecentric lens.
Ma'am, is F theta lens and telecentric lens same?
Sorry, my network was gone for a second. Can you repeat your question?
Is telecentric lens and F theta lens both the same?
No. Both are not same. So
Okay.
first the F theta lens came. So if I can try drawing something on the. So F theta lens came. This is the lens. So if the laser is falling like this, it will try to focus here. Now my build plate is flat, so it will focus my laser onto the build plate no matter where it is pointing. But due to this way of focusing the laser, even if it's focused, if you zoom this, then the laser spot dia has been distorted as an elliptical spot instead of circular. We are supposed to get a circular spot, but we are getting elliptical spot because it's expanding the laser. You know, its arm is expanded. That's why it's elliptical. Now, if it's elliptical, our energy density will change. So that's why telecentric lens came. It's not a single lens. These are the bunch of different lenses, but I'm just showing one lens for the simplicity. In telecentric lens, from whatever direction the laser is coming, doesn't matter because it will always point the laser perpendicularly onto the build plate. Do you remember this thing, this cones, what I'm drawing? This is the laser line actually. Can you find out the difference between picture 1 and picture 2?
Who is telecentric lens? What?
Yes, 2 is telecentric lens, 1 is F theta lens. But can you understand the difference between picture 1 and picture 2?
In 2, it is normal.
Yes, in 2, wherever the laser is falling, no matter what, it will be perpendicular. So the focus spot diameter will be constant and the focus spot will be circular. But in case of F theta lens, even if it's making the laser fall at a focus point on the build plate, but the spot is not no longer circular. It has become elliptical when it's falling at the corners.
It can make it fall perpendicular as well as at inclined f theta.
Yeah. It will be focused and perpendicular. Here it will be only focused, but not perpendicular. This is F theta. So this is the difference. So because of the problem related to F theta lens, the telecentric lens came. Clear?
Yes.
So the fifth question is, so the build area is limited due to the small size of the telecentric lens because the build volume is totally dependent on the size of the telecentric lens. And the increasing the distance between the galvanometer and resin surface will increase the build area. So if you move the galvo scanner far away from the resin surface, obviously you can cover bigger area. If you put the lens here instead of here, and this is your build plate, so obviously you can cover more area rather than in this case. But your galvo scanner also should have, or your F theta lens also should have the capability to focus at this point or from far away. Next is in the context of 3D systems SLA, what should be the gap between the doctor blade and pre-built? So we have already discussed this question. So can you solve it and tell me the answer? You have noted down the formula already, I believe.
It is by 2, no?
Yeah.
By 2. Then it should be 6 by 2.
No.
12.
The
16 by 2.
pre-built, the thing is we are maintaining 6 micron. Sorry, this is the thing we are maintaining. And this is the ultimate result. So the gap between the doctor blade and the preprint layer in order to obtain 6 micron. So this is 6 micron because this is the layer thickness. This is the thing we are maintaining.
Thickness.
Okay. T is always the layer thickness.
The LG is the gap.
LG is what we are maintaining. So here it says 6 micron is the layer thickness. So it's into 2. In the context of, okay, this is also something you need to remember. So in the context of recoating cycle of a 3D systems SLA process, the waiting period required to fade away the visible is called Z wait. We have already seen the Z wait in the order wala question previously. Z wait is also the last step in the recoating cycle for the 3D systems SLA process.
Actually,
Ma'am,
only crease will be there. Solid liquid.
Sorry?
Any crease, visible crease will be there. I think.
So basically, Z wait is there to settle down the resin, for the resin to settle down. If there is any type of hump like this, it can just settle down and it will become plain, as much plain as possible. In the context of 3D systems SLA, the following statements is or are correct. So curtain method is a faster recoating method compared to deep dipping. Curtain method can provide thicker layer as compared to deep dipping method. We will discuss about all the methods in recoating, like recoating, deep dipping, what is deep dipping, what is curtain method, what is recoating. Don't worry.
So deep tipping is an older system, no?
Yeah. First system. Right. Two objects are shown in the picture. So just remember, if you're talking about the deep dipping process, and if you're talking about the 3D systems SLA, where the light will be exposed onto the bill plate, then whether your object, you have placed one object of 100 or 100 of the same object, doesn't matter, the time will be same because it is based on the pixel activation, and the pixels will be activated at the same time, whether one pixel is activating or thousands of pixels are getting activated. The time will be same. So whether it's 1 rod or 1,000 rod, the time will be same, the ratio will be 1. Okay. Next is again, it's perfectory. In perfectory also, so there also it's floodlight or whatever it is, it comes at the same time. If you are putting the floodlight, it comes at the same time. If you are putting the flashlight, it comes at the same time. If you are activating pixels, it will be activated at the same time. So the time will be same whether you are printing 1 or 1,000. It only depends, the time only depends on the height of the object, not the number of the object. Or it doesn't depend on the surface area of the object, rather it depends on the height of the object to be manufactured. Next is, again, can you just guess the answer? envision text perfectory system. What will be the right order?
Trailing should come. Is it B?
So it's exposure, then peeling, then wetting, and then leveling. Which one of the following photopolymerization based liquid AIM system is found to be efficient in manufacturing a hollow spherical object? So it's the perfectory. You will see how it works, why you can print hollow material or hollow part only in this type of additive manufacturing process. Not only, but this is the process where liquid is used. So in other SLA, like 3D systems SLA process, if you're printing a hollow thing, the hollow space will be filled by the liquid resin. But here it will not be. So you'll see why. In the perfectory DMD, the resolution. So it's the same question. Can you solve this question now? The resolution is given, the build area is given. What will be the resolution of the machine or work area setting?
Is it a D?
So it's the same process. The resolution you can just multiply. The work area is given. Print resolution is divide. And then since the pixel is square, we know mostly or in general the pixels are square. So if this is print resolution means this is 1 pixel size. So square it, you know the uh, side of the pixel. And now the machine resolution is basically how much will be the uh, resolution in printing, how much minimum feature size is possible. So this word called minimum feature size is a very common term when we talk about additive manufacturing. People can ask you, what is the minimum feature size possible in this machine? So it basically, how much is the resolution? So if it's saying find out the resolution in millimeter, that means you have to just root it to get it in millimeter as it's square. If it says in millimeter square, then this is the answer. Okay. It's again something to remember. Oxygen is used to maintain some gap so that there will be no attack between the cured layer and the silicon window. Which AIM process uses the water soluble gel? So it's object polyjet. Select the correct option in the context of AutoStretch eDirt. Here the beam correction lenses are not required. And the last question is, in the context of solid ground curing, what will be the order? Just try answering this question.
Solid. Yeah. Photo mask actually we created. Then resin curing.
Creation
Two
of the
ways.
photo mask first,
Okay.
then resin coating. After resin coating, what will you do? Turn on the lamp or place photo mask? So place the photo mask. So the answer will be this one. So just go by creation of the photo mask is the first, then resin coating. These two are matching. Then one
Place the photo
difference.
mask.
So you have to place the photo mask. So this one is correct.
Then turn on the UV lamp.
Then turn on the UV lamp. It's cured.
Is
Uncured
removal of
liquid
uncrystalline
will
liquid.
remove it. Then we have to wax recoating it for
Then wax
the
recoating.
rest of the portion. Of when it's done, we will face mill
Face
some
milling.
of the portion, and then we can final cure it
Final curing.
again in the UV lamp.
So there we are exposing the resin twice now for two UV lamp.
Yeah, so it's the final curing. So after the part is made, in any wet photopolymerization technique, you do the final curing again in the UV
Final
lamp.
curing. Okay.
Yeah.
But this except that three, all other
Yeah.
we are repeating, no? Except three. All other we
Yeah.
are repeating for every layer.
Yeah. So these were the 2 years question on the week 5. I will upload this PPT, don't worry, so you can see the questions later on. If you have any doubt, you can ask me. Now I have an interesting thing. So Anand and Subhash, are you present in the meeting?
Yes.
Are you listening?
Yes.
Yes. So I have the same type of sorry. I have the same type of quiz today as well. So it's a fun game. So can you just join this meeting with your phone? Just scan this QR code and join the meeting. Join this test. It's a quiz. It's a fun quiz. There is no marks for it, but it's just for your better understanding from week 4's lecture. It's not from week 5. So you have already attempted the week 4 question answers. So I believe you will be able to attend it. And it's a fun game. Don't worry. You have to open your Google or your camera and just scan this QR code in your phone. I want to see all 3 of you. Another one is not present. Are you there? Please join. It will be a fun game. There is no marks, but there is a twist. So these marks will not be counted in your final exam. This is just for your better understanding. But in this test, if you answer quickly, you will get more points. And there will be a leaderboard where it will show who is winning the game, kind of. So there is no problem. Even if you don't know the answer, it's absolutely fine. We can just discuss about the question and we can learn the process. Okay, so let's start. So here is your first question. Read the question carefully and answer as quickly as possible. Yes. So two of you answered, or okay, both of you answered. Good. So here if we are having more number of students, then it's a very fun game because you can see who is winning and who is the fastest in which round. So here is your second question. Okay, let's see. So more atoms in the higher energy state than in lower energy state. This is what you mean by population inversion. So more atoms in lower energy state than in higher energy state is the normal process where you get the spontaneous emission. Equal number of atoms is not that much possible, and more number of atoms in the higher energy state is the unnatural process that happens, that is forcefully made in laser production so that we can get the stimulated emission and thus the laser, which is called the population inversion.
Ma'am, so metastable state, is it higher energy state?
So in metastable state means more atoms in higher energy state than the lower energy state.
Okay.
That is not the normal process. Normally it doesn't happen. Okay, so this is our third question. Yes, so monochromatic means only single wavelength. So good. So here is our next question, fourth question. Yes. So divergence similar to a flashlight is not true because it's highly focused. So the divergence is very, very less. Around it's going up and down. So here is our fifth question. Which component of a laser setup is responsible for optical feedback? It's the the active medium is responsible for the generation of those two photons out of the population inversion and stimulated emission. But the optical feedback means after the generation of those two pair of photons from each atom, they start going to and fro through the mirrors as they get reflected from both the mirrors, by which they get highly energized, they get high velocity, and ultimately, when they are having highest velocity and energy, they just go out from the 99% reflective mirror. So that's why optical resonators or those two mirrors are the responsible ones for the optical feedback, whereas the active medium is responsible for the generation of the stimulated emission. Okay, let's see the next question. So the exposure energy and the residue exposure coefficient are directly affecting the curing depth. Each round it's different. Okay. So the small laser spot size generally improves the XY resolution. If it's laser based SLA, but if it's DLP based process, then the pixel size. Okay, somebody is leaving. So in the galvo scanner, mirror position is typically controlled by the closed loop servo motor with optical encoders. Pneumatic actuators is okay, stepper motor, piezoelectric. See, one thing you always remember when you are talking about any optical elements like a lens, to move optical elements, you have to have some optomechanical component. Optical lenses with a mechanical motor combination is very wrong combination. So a trick to answer this type of question is just think in a way there should be something which is optomechanical, not fully mechanical. So it's a closed loop servo motor with optical encoders, because otherwise it will be very wrong decision to move a optical component with a mechanical motor. Okay, because optical components, the reason is the optical lenses and all are very sensitive, because they will be very focused. They will be focusing the laser or the light, so they are very particular in focusing. Their resolution is very high, like the resolution will be sometimes in micrometer plus minus nanometer. So they are very sensitive products. If you're pairing it with a mechanical component to move them, then mechanical components will have some vibration that can destroy the resolution of the optical components. That's why this combination is not very good. Okay. Here is our ninth question. Read carefully. Which factor does not influence maximum scan speed in galvo scanner? The speed of the galvo scanner is no way related to the laser wavelength. Laser wavelength is different, that is fixed. No matter the galvo scanner is working or not, laser wavelength will be fixed. But servo control bandwidth is something related to the servo motor. So the scan speed of the galvo scanner is related to the servo motor optical encoders, obviously. So that's why it's uh, the laser wavelength. So it does not.
Prasad Babu.
10th question. Yes. Okay. Next question. 11th. Which are the following is not a challenge in liquid metal AM? Handling large powder particles is a challenge, is not a challenge in, obviously it's liquid AM, so powder particles are not coming in the picture. So it was again a tricky question. Controlling droplet solidification rate, it's not a very hard to, but obviously it's a challenge. Maintaining, anyway, everything is related to the liquid, and there is only one option that is completely out of the league, that is powder particle. So this is the last question. Yeah. Yes, correct. This is our final leaderboard. Good. But it was a fun test. That was the motive of this test. Okay, so now we have 30 minutes left, so we can start with the PPT. So if you have any choice for the topic, you can tell me. Otherwise, I'll just go one by one.
Ma'am, can you explain deep dipping and top feeding?
Yes, so let me go. Did you attend the last 2 lectures?
Yes.
Your lectures?
Yeah. Like the doubt clearing session.
No.
Record. Okay. This is the recording. Let's start with this one. So here, this is the exposure setup. From this, the exposure is coming. This is the peeling. This is weighting and then leveling. So the recording or leveling where it is there, it doesn't mean that only the resin is coming from top of it. So here it's a vat is used. A vat has been used where the vat is full of resin and this is building on a bill plate. This yellow is the bill plate. This is the
VAT
part.
means container. Is it VAT means container?
Yeah, vat means container full of resin.
Okay.
Okay, so I'm just describing the parts here. So this black portion is a mechanical arrangement by which you are controlling the bill plate movement. Bill plate means the base on which you are printing. Now,
here yellow color is the bill plate.
Yes, yellow is the bill plate. This ash color is the part made.
Okay.
This blue color is the resin.
This is
The
bottom,
vat.
no? Bottom feeding.
Yeah. So now this is the exposure. You can say the exposure is here. Now in the selected area, the exposure.
Is it laser or floodlight?
I don't think it's a laser. It's an UV light.
UV light, yes. Laser
The
means it
laser
is
will
only
not
sharp,
come
no? Like that. It is a single line. It is coherent, no? Yeah.
Sorry, my network was gone for a second. Can you repeat? What did you say?
No, if it is laser will be along a line only because it is a coherent.
Yeah, so it will be
nature.
focused like this. So it will not be laser, it's the UV light.
It is a floodlight. But in laser, one doubt I have, it may be in the UV range we can laser and in green also we can laser. Red also we can we, that is possible.
Yeah.
With different wavelengths, no? All the colors.
Yeah, for different wavelengths, different lasers are possible. But for this vat photopolymerization, as we are using photocurable resins, here, you know, the resins are generally photocurable at the UV range.
At the UV range. And I read that it is a helium cadmium laser. One of the book I read like that. The laser is helium. And,
it can be.
But what does it mean?
Exactly do. Okay, helium cadmium laser means if it's gas, then the same way how the CO2 laser is generated. So in the active medium, the gas will be present and there will be a discharge of the discharge means how you are exciting the gas medium.
Yeah. Along with this light, actually it is photocurable resin we are using. That curing is through laser because laser is a kind of light. Along with the light, that medium is that medium, helium and cadmium.
Yeah.
Similarly, CO2 also.
Yeah, CO2 is also a laser.
Along with
CO2
laser,
is the medium. CO2 is the medium from which the the population inversion and stimulated emission is happening. So CO2 is the active medium or the gain medium. Here the helium cadmium is the gain medium.
Gain medium.
Yes.
So the electrons and all, which are
these electrons going up to the higher energy state, then coming to the lower energy state, these things are happening in the helium cadmium.
Helium, they are belonging to those elements. Yeah.
Yes.
Right. Thank you very much.
Okay. So as the UV light is coming, this portion is getting solidified or cured. This portion, if the part is been made in here, and in the other portion it will be liquid resin only. So this is the layer thickness. Okay. Now when the layer is created, now this is the silicon window on which you are playing. So
the darker
the,
that portion which you highlighted is the part which got cured, is it?
Yeah. This is the next layer that will be cured.
Okay. On top of that structure previously built.
Yeah. This is the previously built, right? This is the next photo.
The feeding is through.
There is no feeding. This is vat full of resin which is already present.
Yeah.
Okay. So now it's solidified and it's shown in same color. What is happening?
So once it is moved up,
can you see my screen?
The direction is plus Z. Can we say the direction of building is?
Yes.
Can we say that it is plus Z?
Yeah, it's plus Z.
So once
since the build plate is facing downwards, won't it be minus Z?
This is the building direction, means this is the way the build plate will move up that I've drawn.
But while in the case of top down, not.
That is the minus Z.
So this is bottom feeding, yeah, is it?
Yes, this is bottom feed.
That way build plate is facing downward, is it?
Yeah, build plate is facing downward. So when this layer is cured, it's shown in the same color. Now, because of the surface tension of the liquid resin that has just got cured, it will be stuck in the silicon window. Okay. So the next step is called peeling, where mechanically you put some force in the upward direction so that the part can be detached from this screen. So you see there is some shaking of the part going on. So using this pillar, we put some mechanical vibration so that the part can get detached from the window. Because of the surface tension, it gets sticky and attached. Do you understand this point?
The lastly cured region will also get peeled off, right?
Yeah. So the whole part will be peeled out from this window, because this got sticky because it's liquid resin which is having very high viscosity and surface tension. So we need to peel off the part from the window so that we can spread or we can let the resin come to the surface. So that's how you peel it, then you move it up, then you move it down in such a way that you have only one layer thickness resin present between the window and the previously built layer. Okay. And
here
then you do the leveling.
So here we don't require any leveling of the layer like Jaffer system we used earlier.
Not like those type of leveling. Leveling means here this part will go down in such a way there is one layer thickness resin present between the part and the window.
And in the top feeding only we have this one.
Yeah.
Jaffer.
Yeah.
Ma'am, what
There
does
is no
weighting
level,
mean?
those kind of leveling. So this is the recoating cycle for this.
Deep
So
dipping also is.
it's called recoating, but the recoating is taking place like this only. There is no physical recoating.
Yeah. Automatically due to gravity, the liquid will occupy the space between the earlier layer and this one. And I think this method doesn't require much resin, no?
No, this process will require, like comparatively, this will not require that much resin.
And whereas in case of deep dipping, and
Then
that
you
from the
require a
top,
lot of resin.
from the top only every time for the last layer it should be dipped.
Yes.
No, more
Yes.
lot of resin you require.
Yes.
Here because of gravity, it is always present in the bottom only.
Yes. So this is the process by which you can actually make a part which is hollow from inside, because
Ma'am,
this is a
what does
downward
weighting mean?
direction. So because of the gravity, there will not be any liquid resin present inside a hollow chamber, inside a hollow cuboid or something.
And you don't require support also. Support structure is also not required.
No, support will be required in any case if it's overhanging. Like if it's too much overhanging till here, then you need some support here.
Ma'am, what does weighting mean?
Which thing?
Weighting.
Weighting means when you pill it up, you put some force to pill it. Like it can be vibration, it can be just sliding to pill it. So after peeling, there will be some turbulence in the resin. So you just put some waiting time for the resin to settle down.
Okay. After that, it is again brought down to level.
Yeah. It will burn down to level. Next, we have object polyjet is simple. It's lot of nozzles will be there from which the resin is coming. And then the UV light is coming. I will show you the deep dipping. So just take this example. In case of deep dipping, this is your bill plate. This one, this black one is your bill plate. Okay. This is your vat full of resin. And this is the part is getting made. This is the laser which is coming. So laser is being exposed and it's curing the resin present over here. So now when this part is made fully till here, now if it goes down, then it will go down in such a way that only one layer thickness of resin will be present onto it. Similar process, right? The line I have drawn is one layer thickness of resin. So just imagine now the part is inside the resin, and on top of the part, one layer thickness resin is present. Okay. Now when it's going down inside the resin, that is called the deep dipping process. Now, if you just try to imagine there is a big surface which is going down. When it will go down, it will not be easy for the resin to come and cover the built surface, because resin is very viscous. Resin is having high surface tension. So that's why there is the time for deep dipping. When the part is having large critical radius, it will take more time in deep dipping than a part which is having small critical radius or critical diameter. So if you see, I would highly recommend you to watch the videos, because there is the lecture video because there is a video on deep dipping, how you do the deep dipping. There you can see the deep dipping is the process by which the previously built part goes down inside the resin, and the resin takes some time to cover the previously built part. Because of the viscosity and surface tension of the resin, it takes some more time than water. And that time is typically dependent upon the geometry, that is the previously built layer or previously built part. So that is the deep dipping process. Do you have any doubt?
So that is why, so recoating is, that process is called as recoating. This one.
This is okay. So now this, in this process, this is called deep dipping. Recoating is another step. In this process, you don't do recoating.
Deep dipping naturally takes place when you
yes.
When it gets down.
Yes. Deep dipping is a natural process. When you go down, obviously the resin will come and fill the upper surface. You then are putting some pressure on the resin by going down.
Yeah.
So obviously the resin will come and fill the upper surface.
Yeah. The Jeffer system we are using.
Yes, one by one.
Making a better layer, a uniform layer thickness, Jeffer system.
Yeah. Yes. Yes. So now if you see the recoating, I don't know, where is it?
Ma'am, so if higher the critical radius, it will take more time, is it?
This is the process, rapid freezing prototyping. It's actually kind of obsolete process. It's freezing, so it's ice you are making basically. It's a good prototyping tool. So recoating is, I will show you the recoating. We already have discussed. This is different. This is different. This is on lens. Where is the deep dipping slice? Slide. Recoating. Okay, just take an example. So if this is your build vat or this is your build plate, so in recoating, what can happen is there can be a recoater from which the resin can come. Okay. And if you move this recoater, you will get a layer full of resin. So this is one thing, which is recoating. Okay.
So doctor's blade we are using.
Doctor's blade you are using to level it. Recoating is also leveling. Recoating is a general term. Okay, recoating is a general term by which you coat the next layer. Inside recoating term, you have various processes. Deep dipping is also a type of recoating. This the fan system is also one recoating. The SLA system is also, perfectory is also a type of recoating. But there is another system in recoating in which there is a nozzle that you use, which is coming under the jet, liquid jet process, through which you are putting the resin onto the build plate. You are putting one layer of resin onto the build plate.
Complete layer.
Complete layer onto the build plate, like solid ground curing. And then you put the mask on, you just do the exposure. When it's done, you remove the mask. This is the process. So here, first, resin recoating. So this is the recoating process. So this is a recoater through which the resin is coming itself. So you are moving the recoater. So basically you are putting the resin onto the build plate. And then you put the mask on, expose it. So after exposure, you can remove the resin from it. area where the exposure didn't take place. Then you do the wax recoating. And then if you do milling operation, then only you mill where the part was made. So now you have a part where this is wax and this is resin filled. Now you do the final creating again, and this is your last part. So final curing is the last process. After this step, in each step, you will recoat the resin again. After this, you do this again for each layer. Now you understand what is recoating?
And the center white portion is what we will cure, right?
Yes, white cross with a hole.
Okay.
Okay, so this is the recoating process.
So doctor's blade and Jaffer are two types of recoatings.
Yes, so now doctor blade, I will tell you the working of doctor blade. If you see this process where you deep dip it, now after deep dipping, what we generally do is we don't deep dip, like we don't go down exactly by one layer thickness. We go down extra and then we move up so that there is one layer thickness of resin present. Understand this point?
Yes,
yes. Once more.
Okay, so in deep dipping, what I said, that you go down by one layer thickness in each step, but this process actually doesn't take place. What takes place is it goes down little extra and then it moves up in such a way that there is only one layer thickness of resin present onto the pre-built part. It goes extra down
one more layer,
and then
one
move
more
up.
layer extra will come after it goes down and come back.
Yes.
Okay.
So in case of deep dipping, if you see, if you are going just one layer thickness down, then you need to understand the reason also. If you are going down by one layer thickness, the one
takes
layer
more
thickness
time.
is, sorry?
It takes more time to
it takes more time because
layer.
it's just 20 or 30 micron. So that's why we do this. Now, when you do this, there will be turbulence and there will be, because of viscosity. If your part is like this, the resin will be like this. So now you take the doctor blade. You keep the distance between doctor blade and the pre-built layer as LG. And then you move the doctor blade onto it. So the doctor blade basically evens out the upper layer. Ultimate layer thickness will be TG. Now you remember the formula, TG equal to LG by 2?
Yes.
This is the process. So if you are doing only deep dipping, it takes time, through which you are getting the formula that deep dipping equal to, or deep dipping is proportional to the critical diameter of the part. And when you are in actual, deep dipping will not help. So you do this extra, go little extra and then come up. In that case, you use the doctor blade to make the upper surface plainer.
Plain. That is to ensure a uniform layer thickness.
Yes.
Ma'am, what does critical diameter mean actually?
So critical diameter is basically, if this is your part, for example, this square. Critical diameter of this square means if you can fit the largest possible circle in it, that diameter of the circle. In this case, this square, the largest possible circle is this much. It may happen that the area of this part and the area of this part is same, but the critical diameter is not same, right? So this will take lesser time than this part for the resin to cover.
But in the case of this deep dipping, where do we consider this critical radius?
So when you deep dip it, deep dip means, or deep dipping means, you are not going extra down. You're just going down by one layer thickness. That is 20 micron or 30 micron. in that case, how much time the resin will take to cover the surface?
If the critical radius is less, within less, it is within less time.
It can cover.
So
Maybe area may be more.
But this critical radius, will it be on the top of that previously built portion?
Yeah.
Okay.
It's a cross section.
So if your part is like this, you take the highest possible, and that is the critical radius.
So this is the top view. What you have drawn is the top view.
Yeah, top view of the previously built part or layer.
Yeah, actually that detail will get from the slice, no? Slice.
Yeah.
From the slice file.
Yes.
Thank you.
Sliced each layer.
Okay.
Okay.
So we have discussed the bottom feeding as well as deep dipping. We have discussed now.
Yeah.
What about
top feeding also we have discussed. This is top feeding.
Okay. First we will do photomask creation. That's this white color portion. Light color portion.
Creation of the photomask. Photomask means
dark color region. Dark.
Yeah. This white color is, just imagine a paper, A4 sheet, where you have cut out this portion, okay? And in this portion, the paper is in such a way, it's made of such a type of material that is not transparent to UV light. So when you place this on top of the resin and then expose the UV light, obviously the UV light will reach the surface only in the white portion, which is the cutout part, not in this gray portion. So that's how you pick the part.
Yeah, that is uncovered. Cover and uncover.
Yeah. Uncovered, yes.
It means it is covered.
Yeah. This is covered, this is uncovered. Any more doubt? If no, then we can stop the session here.
Yeah, because the methods are, many methods are there. That is why remembering all these methods is a challenge.
It's a little bit difficult, yes. Okay, then we can stop.
Regarding week 4, I will go through the solutions, and if there are any doubts, I will let you know in the next session.
Yeah, sure, please. Okay, so we'll meet in the next session.
So actually, I think on August 18th, supposed to be a session by the resource person, but that
August
is not.
18 is already gone.
No, yeah, but that time it is not actually. That session was not happened actually.
Okay.
Is that you are aware of that or not?
No, I don't know. I also get the mail, but I didn't attend, so I don't know anything, any news.
Thank you.
Thank you for attending. Bye.